this is the second last bogie, and the passenger is here. Oh. Then after what time? So the passenger position, it will not change. No, you will be there only. Then the time taken by the last bogie, second last bogie, to pass through that information is available. So you can bring it here. So this is what, 3 seconds. And the last bogie takes 2 seconds to pass through it. Very difficult to draw. I'll put it here. The last bogie. Two more seconds, it will take it. Hope everyone is able to understand now. The passenger for the departure of the train is late by what time is late? Is telling. So let this velocity be u. I'll write it. Let this be v. And the train is going to accelerate. It is going to have constant acceleration. Let the L be the shall we write equations of motion? L is equal to u into 3 plus a 3 square by 2. There's a one equation. And further, v equal to u plus a into 3. Then again for this particular bogie to pass through it. So what is L? L is equal to v plus 2 plus a 2 square by 2. Okay, what are these equations? You see this, look at this bogie. I will color it. Now look at this one. This bogie will take this bogie will take 3 seconds. The last one bogie, what happened, will take 3 seconds to pass through it. And the last bogie will take 2 seconds to pass through it. So what is the length of each bogie is L? And this was at t equals 0, it was the train was accelerating. Now the passenger will arrive, and it arrives. What happened? The train was having velocity u. So now what is the question like? The passenger for the departure of train is late by what time? Okay, earlier the train definitely might have started. We don't know, somewhere here is what the train might have started long back. By the time when passenger is, you see the last but one bogie is what? In front of him. I will push it a little bit more. I could have written directly the equations, but through diagram it will be better, no? So we have to calculate that particular time now. So are you getting now? So this is the delta t. So I think you can understand this equation. So what is L is equal to now? This particular bogie, it will cover a distance L. So this should be equal to u into 3 plus a 3 square by 2. By the time the front end of the bogie, by the time the bogie covers a distance L, what is the time taken will be 3 seconds. So this equation will write it. Now for the last bogie to pass through the passenger, this will become initial velocity, no? So this will become initial velocity. This v will become initial velocity. So what is u? U is the velocity of the train when the second bogie is just crossing the passenger. What is V? Velocity of the train when the second bogie has crossed the passenger. Now for this motion, for this interval of time 2 seconds, this will become initial velocity. That's what we wrote it here. Okay, what all information we have? Like a L length of the, okay, I'll equate these two. I'll substitute V here. Then I'll get U and D. V equal to U plus 3A, this is that. So I'll substitute the value of U. I'll get U and 3. I'll equate these two. I'll equate these two. Then, okay, we'll do one thing. I'll solve it. Equation 1, 2, 3. Okay, put 2 in 3. When you put 2 in 3, so this will become L is equal to V. V is U plus 3A by 2 plus 2A. 2U plus 6A plus 2A. Now by 4 and 1, equating, we'll get a relation between U and D. Okay, 4 and 1. By equating 4 and 1. So 2U plus 8A is equal to 3U plus 9A by 2. Solving this, I'll get relation between U and A, which is 7A by 2. We have to calculate the delta T. We have to calculate that delta T. Okay, now what is the thing that one? It was, train was at, from rest, it will accelerate. So therefore, what is U? You can write it here. The velocity of the train after time delta T. That should be equal to, U should be equal to A into delta T. So what is U equal to? 7A by 2 equal to A delta T. Delta T is equal to 7 by 2 seconds. Let me write it here. This is the time interval. Okay, you have to fight with the information. Nothing is there.